Have you ever wondered why the Earth occasionally turns into a giant snowball, plunging into what we call an ice age? Yes, those periods when the Earth's temperatures drop dramatically, and ice sheets expand across the globe. It's not just a random event, it's a periodic phenomenon, an intricate dance between the Earth and its atmosphere. Ice ages are not just about massive glaciers and woolly mammoths, they are about the transformation of Earth's climates, landscapes, and life forms. Imagine the planet's lush green forests and vibrant ecosystems abruptly replaced by vast, desolate expanses of ice. Countless species adapting, evolving, or vanishing in the face of such drastic changes. This natural spectacle has been replaying itself over billions of years, a testament to Earth's incredible ability to change and adapt. These ice ages, these massive global transformations, are part of the very fabric of our planet's history. It's a fascinating puzzle, isn't it? So how does an ice age begin? Imagine, if you will, a world that steadily gets chillier and chillier until vast sheets of ice cover the land. This chilling scenario isn't straight out of a science fiction novel, but rather, it's the birth of an ice age. First, let's get a grasp on what triggers such a drastic change in our planet's climate. The key players in this icy transformation are changes in the Earth's orbit and tilt, solar radiation, and greenhouse gas levels. Each of these elements creates a domino effect that ultimately cools our world. The Earth doesn't orbit the Sun in a perfect circle, but rather in an elliptical pattern, and this orbit changes over time. This phenomenon, called Milankovitch cycles, affects the amount of solar radiation or sunlight that the Earth receives. When the Earth's orbit is more elliptical, it receives less sunlight, leading to cooler temperatures. Compounding this, the tilt of the Earth's axis also plays a significant role. As the tilt changes, so does the distribution of sunlight across the Earth's surface. Less tilt equals less sunlight reaching the poles, resulting in colder polar regions. Now you might be thinking, well, what about greenhouse gases? Don't they warm up the Earth? Yes, they do. But during the onset of an ice age, their levels drop. This decrease in greenhouse gases, particularly carbon dioxide, reduces the Earth's ability to retain heat, contributing to a further drop in global temperatures. And here's the thing, these elements don't work in isolation. They interact in complex ways that amplify the cooling effect. For instance, as ice sheets expand, they increase the Earth's albedo, or reflectivity. This means that more sunlight gets reflected back into space, instead of warming the Earth, leading to even colder temperatures. As these factors align, the world begins to chill, and the stage is set for the birth of an ice age. Vast sheets of ice advance, transforming the landscape and creating an entirely different world from the one we know today. So we've seen how an ice age starts, but what happens next? In the grip of an ice age, the Earth is a drastically different place. The once lush and verdant landscapes are transformed into frozen wastelands, seas retreat, making way for expansive ice sheets, whilst mountain ranges are crowned with glaciers. The climate is harsh, with temperatures plummeting to extreme lows. Biodiversity too undergoes a stark shift. Plant and animal species face a brutal test of survival. Some species, like the woolly mammoth and the saber-toothed tiger, adapt to the bone-chilling conditions, their bodies evolving over generations to withstand the frigid temperatures. Others embark on long migrations, seeking refuge in warmer climes. Yet, many are not so fortunate. Unable to weather the icy storm, they are driven to extinction. In this frosty world, life is a constant battle against the elements. Every creature, every plant, is locked in a struggle for existence, a testament to the resilience of life in the face of adversity. As life on Earth battles these icy conditions, the question remains, how does this frigid era end? Eventually, the icy grasp of the Ice Age loosens, leading to a world that's more familiar to us. As the Ice Age wanes, a combination of factors comes into play. One of the most influential is an increase in solar radiation, which warms the Earth's surface. But that's not all. Higher levels of greenhouse gases, such as carbon dioxide and methane, are significant contributors to the warming process. They trap heat within the Earth's atmosphere, further accelerating the thaw. As the ice sheets melt, they dramatically reshape the world. Sea levels rise, swallowing up land and creating new coastlines. Landscapes transform, with lush vegetation taking the place of barren, icy plains. Life too adapts to these changing conditions, evolving and diversifying to fill these new habitats. The world as we know it begins to take shape. And thus concludes the cycle of an ice age, a remarkable testament to our planet's ever-changing climate.